The reason a lot of SAT takers get stuck in that 650 to 750 math score range is because of these pesky Module 2 questions that look like something you've never seen before. But more often than not, they're not actually new at all. The SAT is a super predictable test. The same question types appear over and over again, just disguised in different ways. And what separates the top scorers is that they've cracked the code and know what to expect before they even walk in. I'm a 1600 scorer, and after spending hours breaking down real past SATs, I've narrowed it down to 5 math questions you will see on the June SAT. Let's get right into the questions. Alright, starting off with question 1, a geometry problem testing scale factor in similar shapes. So these kinds of questions have shown up a lot on previous SATs, at least one in each administration. So you should definitely feel good about these topics. Okay, so for the problem itself, we have two right rectangular prisms, X drawn on the left and Y drawn on the right. We're told that the surface area of prism X is 56 square centimeters and that the surface area of prism Y is 2016 square centimeters. We're also given the volume of prism Y, 5,184 cubic centimeters. So our goal here is to find the volume of prism X in order to find the sum of the volumes of these two prisms. So if you read the problem, a key detail you notice here is that the prisms are similar, meaning that all their corresponding dimensions, like their length, width, and height, are in the same ratio. So now when two shapes are similar, they have a scale factor, the number that tells you how much bigger or smaller one shape is compared to the other. And from that single ratio, we can figure out how things like surface area and volume compare. Specifically, surface areas scale with the square of the scale factor, and volume scales with the cube of the scale factor. Now to illustrate this, let's give x and y sample dimensions. So let's say that the length of prism X is 8 and the length of prism Y is 16. And let's say that the width of prism X is 6 and the width of prism Y is 12. The scale factor here would be 2 because that is what you multiply the dimensions of X by to get the dimensions of Y. However, you can't apply this to surface area and volume. That is to say, the surface area of Y would not be 2 times the surface area of X, even though the scale factor is 2. Since surface area is measured in units squared, the scale factor has to be adjusted to reflect this degree, meaning that it should be squared. And this applies to volume too, meaning that the scale factor should be cubed. So now that we understand how this whole scaling thing works, we can do this problem relatively quickly. So we have both surface areas, so all we need to do is divide them to find the surface area scale factor. So y surface area is 2016 and x is 56. And if you divide these numbers, you get 36. So let's call that k squared, where k is a regular scale factor because this 36 is a area scale factor. So we need to find what k on its own is in order to find k cubed, which would be the volume scale factor. So k squared, if k squared is 36, that means you take the square root of both sides to find what k is. So the square root of 36 is just 6. And now you can plug in k6 into k cubed over here. So 6 cubed would be 216. And that right there is your volume scale factor. So now all we have to do is, since we have the volume of one shape and the scale factor, the volume scale factor, we can just do 5,184 divided by that scale factor, which is 216. And that's going to give you the volume of X, which is 24. And since the problem asks us for the sum of these volumes, you just have to do 24 plus 5,184, which will give you a final answer of 5,208 cubic centimeters. Alright, moving on to another geometry problem, this one testing your understanding of right triangles and triangle altitudes. We're told we have triangle ABC and that angle B is 90 degrees, meaning that triangle ABC is a right triangle with the right angle at point B. We're also told that BD is an altitude, so it goes from point B and connects to side AC over here forming two smaller triangles inside the bigger triangle of ABC. We're also told that AB is 24 units, and AC is 13 more units in comparison to AB. So AC would be 24 plus 13, or 37 units in total. And our goal is to find the value of BC divided by BD. So since triangle ABC is a right triangle and we know two of its sides, we can use the Pythagorean theorem to find side BC. So this is just going to be AB squared plus BC squared equals AC squared. So AB squared, or 24 squared, or 576, plus BC squared equals AC squared, or 37 squared, which would be 1369. Now if you do the math, you are going to get BC has a square root of 793. So now we have to find BD. You can do this in a lot of ways, but I prefer to use triangle similarity because it's really convenient when you know what you're doing. All you have to do is set up some ratios. So we can set up ratios using the side lengths of the bigger triangle ABC and the side lengths of the smaller triangle here, BDC, because BD is within this triangle BDC. But first, we have to orient them in a similar manner to set up accurate ratios. And one thing you should know is that these two triangles are inherently similar, which we've discussed in the last problem, because BDC is embedded in the triangle ABC. So here, since we get a right angle at D, because when these two lines intersect, they form a perpendicular area, which means there's a right angle right here, we can put D right here on the smaller triangle. So basically we have two right triangles here to express this similarity, and because the right triangle is right here, you can just put that right there. So we know that BD is the smaller side, so B would go right here at the top because AB is a smaller side right here, and since B would be similar to A right here, B would go right here, and then C would go where it is in the triangle ABC. So now that we know that we have these triangles similarly oriented, we can set up ratios. Since we're trying to find a ratio similar to BC over BD in triangle ABC, this is how we're going to set up ratios. In a way that these side lengths are going to be oriented in a way similar to these side lengths, the way these are arranged. So since BC is similar to ABC's hypotenuse of AC, we can put 37 up top, here and here, and we can put a 24 at the bottom because ABC's height of AB is similar to BDC's height of BD. So that gives us the ratio as 37 over 24, our final answer. So essentially, AC over AB is equal to BC over BD because we have oriented these triangles in a way that expresses their similarity in ratios. So because you have hypotenuse AC, which was matching the hypotenuse BC, and the side length AB, which is matching the side length BD, you can just say that AC over AB is 37 over 24, which matches with BC over BD. And that's how you get C. Alright, moving on to question 3. So every SAT I've seen or taken tests you on some super weird constant related function problem. And it may seem pretty confusing at first, but once you realize that you have Desmos at your disposal, it becomes super easy. And the way you recognize that this is a problem you can use Desmos for is you have a function, which you can model using Desmos, and you have a constant, which you can use regression to solve, also in Desmos. So you don't need to know how to do it, or you don't need to use your hand at least. So let's just model this using more relevant terms. Instead of k of s, you can just use f of x equals, to get the cube root, to get the cube root function, you have to use a shortcut of CBRT. S is just x, and plus 110. Okay, now you have that. We can also just type this in exactly in Desmos. It may seem like you can't, but you can using the regression tool. So instead of k of 53p, f of 53p, and then use the tilde sign, which is under the escape key at the top left, shift tilde, to do a regression. And a regression basically means it'll estimate the value of p equals p squared. And that's it. You don't have to do any work. Just understand how to translate the problem given to you, put it into Desmos, and you get the value of p right here. 2.49691. The SAT wants you to round that, so 2.5, and boom. You don't even need to know how to do this. You don't need to know the ins and outs of the problem because you have Desmos. So my suggestion is master Desmos and then use the time that Desmos saves you to work on these harder problems that may not be solvable through Desmos. Okay, moving on to question number 4. So, percent questions like these have shown up a lot on recent SATs, specifically the March and May versions. So it'd be highly beneficial for you to learn how to accurately do these kinds of problems, especially on Desmos, more efficiently and accurately. So let's get right into the problem. A researcher investigated 2 species of mites, a predator and its prey. At the start of the week, there was an equal number of the 2 species, a very important detail. And at the end of the week, the number of prey had increased by 2,300% of the number of prey at the start of the week. And the number of predators had increased by 380% of the number of predators at the start of the week. The number of prey at the end of the week was p% greater than the number of predators at the end of the week. So prey is something more, so it's p% greater than predators. And what's the value of p? So here, a lot of people would choose to just define your variables as x or something and then go from there. But it's actually easier to just pick a random number because anyway you know that there's the same number of predators and prey. So you can just start with a number that's convenient for you. For me, I'll use 100. So let's just say you start with 100 prey and 100 predators. And you can use the percent of function on Desmos to accurately model the increases the problem is talking about. And how you do that is just do shift and percent and you get percent of. So to show a 2,300% increase, you're just going to do 100, your initial, plus that 2,300% increase for the prey. And the same thing for predators. 100, you're starting, and then that 380% of that 100 shows that increase. So now you're left with 2,400 prey at the end of the week and 480 predators at the end of the week. And now they're asking, the number of prey was p% greater than the number of predators. So because you're trying to find the number of prey in relevance to the number of predators, you know that the number of prey is going to be isolated in your equation, and whatever you are doing is going to be on the side of the predators. So let me model that out for you. So 2,400, that's just going to be isolated, and you're looking for this in terms of the number of predators. So, okay, at the end of the week, you're left with 480 predators, right? And then they're asking, the number of prey was p% greater than the number of predators. So 480 plus p% of 480 is 2,400. And through the regression feature in Desmos, which I've discussed in the last problem in the video, so go back to that if you need to understand how to perform a regression. Using that tool, you can just get the value of p as 400. In other terms, the number of prey at the end of the week was 400% greater than the number of predators at the end of the week. And how I did that was I just modeled it based off of how it worked over here. So yeah, use Desmos and be more efficient. Moving on to our last problem for this prediction video. Okay, so we're given 2 triangles, PQR and LMN, graphed in the XY plane. here in Desmos for y'all. I have the points labeled for y'all, and then k equals 1. So if you read the problem, you can see that they say k is a positive constant. That means when they say that, you can just label k as any positive constant you want. And if you play around with the slider a bit here on Desmos, you'll notice that whatever you set k as, it doesn't matter. It doesn't change the triangle in its shape itself. So you should just pick the most convenient number for you. So we're given these two triangles, right? And the first triangle, PQR, has the points P equals 3, comma Q, Q equals 3, comma 8, and R equals 7, comma 4. So you'll notice that PQ is a vertical line and PR is a horizontal line. And that means that triangle PQR has a right angle at point P. It is pretty evident right here. Now the problem tells us that angle Q, another angle in this triangle, has a measure of T. Since the triangle is a right triangle and one of the angles is 90 degrees, the third angle must be 90 minus t degrees. That is because you already know that you have P as 90, you have Q as t degrees, so by default the last remaining angle, angle R, must be 90 minus t. This is because this has to happen in order for this to be a valid triangle, which all sides must add up to 180 degrees. So keep that in mind as we move on to triangle LMN. It has the points L equals 3, comma 4, M equals 3, comma 8 plus K, and N equals 7 plus K, comma 4, where again, K is any positive constant. So if you look closely, you'll notice that triangle LMN is essentially the same shape as triangle PQR, just stretched upward and to the right a little bit. The vertical side got taller, and the horizontal side got longer, but the triangle is still right angled at point L, because one side is vertical and one side is horizontal, just like the previous triangle. And since triangle LMN is also a right triangle, and the right triangle is at L, the angle at point N must also be the complement of the angle at M. That means it has the same measure as angle R in the first triangle, which we already figured out is 90 minus t degrees. And therefore, your final answer is going to be 90 minus t degrees. So that's it for the predictions, but for some more general tips, College Board always takes problems from Blue Book practice tests as well as their SAT Suite question bank. I've experienced this, and because I've done all these problems before my perfect score, I was able to actually get some same concepts or same questions on my SAT. So if you're aiming for the highest possible score, you should definitely have those done, as one of those questions amongst all of those will definitely show up